Right now we have Michał Kostrubiec.
Kostrubiec.
Kostrubiec. Who's sorry, thank you. Apologies.
No problem.
Who's not online is FractalFir, which is way easier for me to pronounce, and it is presenting for the second time here at Rust Week. Previously about some work on compiling Rust to C, and now about an extension that compiles to .NET. I think it's super cool stuff, and I'm really excited.
Yeah.
So let's welcome Michał.
Yeah. So a lot of the code is actually shared between the C side of things and the .NET side of things. It's technically speaking the same project, but also not really. Like the difference, like I believe a couple thousand lines of code. So I think once again, as I did with the compiling Rust to C, like I think it's important to say why I'm doing this. And like the one answer is obviously for fun, but another is that I'm kind of researching what are the limits of interoperability between Rust and .NET. And my project compiles Rust to .NET assemblies. This is the format that C# and F# compiles to. Really, from the perspective of the .NET runtime, my Rust code kind of looks like some weird unsafe C#. And this allows me to do things like allow Rust code to directly call a C# API. Here we have here we receive a reference to a class, and interestingly, you can actually hold references to .NET classes in Rust. This is like code that more or less works today. I will later have some examples that are a bit more out in the future, but right now you can accept a reference to a .NET class in Rust code. You can call its functions like normal functions, virtual functions. You can access its fields, and the idea is basically to make kind of see how far we can go with interoperability between those two different languages. Because like one of the biggest reasons people don't want to mix languages is the friction on the interop layer, and if we can reduce this friction as much as possible, then maybe it will be slightly more feasible. Additionally, like since this Rust code is compiled to a .NET assembly, from the perspective of the C# code really doesn't look all that different from a normal C# function. Like here I use a class named Rust, like as an example. You can later on I will show like the way you can. There's a way currently slightly in progress of you defining .NET classes in Rust. But like if I name this class something different than Rust, I don't think you will be able to tell that okay, this is like something different from like your standard C# code. So that's more or less the idea, to expose as many capabilities of the .NET runtime to Rust code and to allow you to mix them together as easy as possible. So here we have like some of the things that are currently highly work in progress. I am currently seeing how I can use macros and some compiler side tricks to allow you to define .NET classes. Like right now I'm doing something quite weird to do this. Actually this will compile down to a Rust function that gets interpreted at runtime to create the .NET code. So that's more or less the goal of the project. The goal is to allow people to write .NET assemblies in Rust and for you to be able to use .NET code from Rust easily. Like as you can imagine, there are quite a few of .NET libraries and like quite a few Rust libraries, and I feel like both ecosystems could benefit from such a thing. For example, like .NET has a garbage collector, which has some overhead, and imagine you may have some large set of data that would live for a couple seconds and then would die. So .NET would actually have to take quite a bit of time to reclaim that. You would have to wait for a major GC pause. And if you write that code with Rust, you could kind of get the memory freed slightly earlier. So that's more or less the idea. Like in cases where it's the performance matters more than ease of use, you could drop down to Rust. And like maybe I will talk a tiny bit more about how this all works. So Rust C code generator is a compiler backend. You can kind of think of this as a compiler plugin. So it can be loaded at runtime. You can actually use this with an unmodified Rust compiler. And as I said, from the perspective of the .NET runtime, there is no difference between Rust and unsafe C#. Here we have an example of a Rust function that was decompiled back to C# because the way the ER is designed, it's designed for you to be able to easily go to the ER, from C# to this ER and back to C#. So here we can kind of see how this would look from the perspective of the .NET runtime. Like you have an option. I have once experimented with translating Rust generics to .NET generics, but I have concluded that it's not really feasible to do this in a way that's both performant and like fully correct, and also looks kind of nice. So for now, they are distinguished by the hashes. Like it is a limitation that you cannot share like a generic type with .NET, but you can do quite a bit of stuff on Interop. Like to give an example, because the .NET code is just in compiled, there is really no issue with layout stability, because each .NET assembly contains full information about the layout of a type. You can actually safely send to .NET a Rust type with a Rust layout, and the .NET code will actually adjust depending on what the layout of the type is. So if you recompile that, and if the compiler settings change, if the layout of the type changes, it will change on the .NET side too, which is quite nice, I feel. I don't actually compile this down to C#, I compiled it down to what's called CIL, or Common Intermediate Language, and this is what our .NET assembly contains. You may wonder, like, what is it? Like, it's a form of bytecode. I like to think of bytecode as sort of instruction set for a made-up CPU. So we can kind of think we have an imaginary CPU that executes .NET instructions, and the JIT compiler is actually then responsible for turning that into native code. Here we once again have an example of a Rust function. I believe this one is using iterators. We have a range here, as you can see. And since we are not referring to fields directly, we are referring to them using this load field address instruction. As you can see, like the layout can actually be adjusted. So that's more or less the goal of my project, and that's more or less what it actually does. So compiling Rust to .NET will hopefully allow for very deep and seamless interop. As I said, you can define in the future, you will be able to. The syntax for defining classes is actually not fully ready yet. Like you can define very simple classes, but I want to be able to handle as many cases as possible. So I don't consider it to be ready yet. But you can already like call .NET APIs, construct new instances of .NET classes, so you can actually call constructors and have like full access to GC managed classes. I know that there will be questions about how you can ensure safety of that. I have spent some time on getting diagnostics that will detect misuse of .NET features. So while I'm not yet confident that it's fully safe, and the messages could be way better because they're currently quite ugly, they will catch quite a few cases of like you misusing misusing .NET APIs. Yeah, so basically this is the goal of my project. I've been working on this for about 1.5 years now. It can compile already most of Rust code, and I kind of hope to, in the future, maybe this will allow for those two ecosystems, the Rust ecosystem and the .NET ecosystem, to be slightly more interconnected. Yeah, so very much like thank you for listening. If you have interested, you can like look at my social. I will also be on the kind of the Ghosting spotlight. So I will have a spot there. So if you have any question about compiling Rust to .NET and compiling Rust to C, I will be sitting there and I will be ready to receive your questions. If you don't manage to find me there, you can, or have a question later, you can also, as I said, write to me on GitHub on my social, like. Just contact me and I will be more than happy to talk on about this project for hours, because there is quite a bit of stuff to talk about. Yeah.
Well, thank you very much.